For example, axial tilt. The angle is to the very precise numbers. The universe is full of such specific values. In the universe.
When it comes to fine tuning, sort of two levels of tuning this about. The first level of fine tuning, why do the laws of physics have the constants that they have? For example, the speed of 300 to the 8 meters per second. So that's the question. Be some value. Maybe it would have been 2. It could have been 2 to the 8 per second. 4. And is it? We just have 3. That may not be special. Turns out it is special. That you can deviate from the 8 per second very far. Conditions for in the universe are not. Is one example. Gravitational. If the gravitational constant is too strong or weak, it has a very big effect on planets. The forces inside the nucleus, strong nucleus, the weak nucleus forces, those parameters are also fine-tuned. The sun is powered your process where and helium and beryllium and carbon, oxygen, theories of nuclear reactions. It turns out that levels of each other to make it happen. If they were different, that there would be of oxygen, for example, or little production of oxygen. And so what we find is that the universe is very fine-tuned in terms of nature. Those things are to be the same all over the universe, but the value itself is a very special value. And the value is conducive to life in the universe. So that's the fine-tuning of the universe. Even a universe that is so spectacularly as ours seems to be, extremely tuned. When you have this universe, ask the question, how easy, how expected to have a planet? Be talking about, well, what are the processes that produce a planet? There's a proto-planetary disk, there's a aggregation of material, there's the formation of the planet, there's the bombardment that occurs because of material in the universe, and the proto-planetary disk. Then there is stellar formation that is going on. Where are you forming? It turns out that, in other words, even in a very friendly universe like ours, exceedingly well designed like ours, and then when you ask the question, for operating in this universe, would they produce many, many Earths? Like if we go to the next star, are we find another? Well, we're understanding now what are the conditions mean when we say an Earth. On a terrestrial, for example, in our own solar system, the Earth is a terrestrial, meaning it has rock. It's rocky, but it has rock. But if I go to, it's not that kind of a planet. If you arrive at Jupiter, it is just a gas, and the pressure builds up rapidly as you descend into the life. So you need a terrestrial planet. You want too much water because you have to have an interface between land and water. Water small enough that there is a combination of moisture and there is a combination and sunlight that penetrates the water. Warm waters, that much of in this occurs in the places where water is touching. When you go really deep, there's not enough sunlight to produce. And then ask, what is it to have a climate that is stable? Earth's the seasons, but it also that is not doing this as we go. This is not the case for our Mars, for example, stable axial tilt. This is actually become have this the Earth-Moon system, part of a system that is really designed to have a stable climate. The Moon is doing multiple things for us. It's not just there randomly. It has a job. We can talk about Jupiter. Jupiter has a job to the Earth, and the job that Jupiter's mass is so high that it absorbs to itself. It's gravitational attraction. It sweeps and cleans up the debris in the inner solar system. For example, it was much younger, 20 years ago, there was the Shoemaker-Levy. He was excited. It was in the news. And would get out their telescopes and watch this comet. Eventually, what happened to this comet? It crashed. That's what Jupiter does. We're thankful to Jupiter because things the near-Earth objects that could sometimes do, collide with the Earth. The fact that they don't do that more often is because of a massive gas giant, which Jupiter is, chemical unit orbit electricity. That the orbit of Jupiter is almost orbit. Is that of the Earth? Now, can for a very period of time it can collide with the Earth out of the solar system. This never happens because Jupiter is so well mass electricity is what are combined. And so it is the principle that's supposed to be there, that of what's called the principle of measurability, that we are special view of ourselves. Find is in reality that things are extremely well matched to our planet is well protected. Moon doing what it's doing. We have the magnetosphere. The magnetosphere is protecting us from solar activity. So the list is a very long list, and so there is one long talking about all in this case, about the survivability.